So for today, number one, okay, number one, integrate 3x squared, no, 3x plus 4 with respect to x. Integrate that for me. Should just write down the answer, really. Number two, find the area underneath that line, that red line between 0 and 4. So you've got a little trapezium type shape. So one way to do it would be to split it into two parts. Find the area underneath anyway. Number two. Number three, there's 5 little rectangles, and these numbers represent the height here of these rectangles. And the width of each rectangle is 2. If I told you that the area was 57, and I said to you, find out what 57 divided by 10 was, what does that tell us? What number does that tell us about that picture? If you pause, if you look at the video, pause it, have a think about them, and then I'm now going to go through the solutions. So number one, integrate 3x plus 4. Answer? Somebody? Right. Good. Well done. Thank you. Add 1 to the power, divide by the new power, gives us 3x squared over 2. Integrate 4, the variable, whatever it is, and in this case it's x, reappears, so 4 becomes 4x, and then we always have this constant of integration, c, at the end. Good. Number 2, anybody come up with an answer for this one? David? 14. Sorry, 40. Any agreement there? Okay, 40, good. One way, is this the way you did it, David, would be to sort of split it, find the area of the rectangle and the area of the triangle. Okay. Number 3. So if I divide 57 by 10, I get 5.7. What does that figure tell us about those? Well done, yep, it's the average height. Yep. If I were to draw a rectangle, 5.7, so this is 5.5 here, so it'd be slightly higher than that. So if I drew a rectangle here, 5.7, that area would be 5.7 times 10, which is 57. So that represents the same, that area is the same as this area. So it's the average height. That 5.7 gives us the average height. And what we're going to do today is use integration to look at as a method of finding the area under a curve. So if we get a complex function, something like this, then we can find the average value of that function between 2 points, say there and there, by finding the area and then dividing by that distance there. So a really handy way of using integration to find average values. So today is all about using integration to find the area under a curve and then to find average values.